Hello and welcome to the latest in our webinar series. And today we're going to be talking about how to build sustainability into your plant-based processing lines with a particular focus on homogenization. Let me start by introducing myself. My name is Con O'Driscoll. I'm a global product manager at SPX Flow. I'm based in Southern England, and I've been in this role for a good number of years at SPX Flow. And prior to that, I worked in engineering and application roles. And today I'm looking forward to sharing with you some details of how homogenization can have a very positive influence on your plant-based processing lines and challenges in today's world. A few housekeeping notices before we begin. As an audience member, you don't have audio and video access on this webinar. However, there will be an opportunity at the end of the presentation for questions to be submitted, and we'll work to answer as many of those questions as possible. And in case we don't have time to get to all of the questions, my details are included and there'll be an opportunity to send them afterwards, and I can get in contact with you to share the information. So let's get started. Firstly, I'd like to share our purpose statement at SPX Flow, which is to improve the world through innovative and sustainable solutions. And we do that through a combination of many factors. And firstly, through our people and our locations around the world. We truly are located in all parts of the world at SPX Flow. We have our innovation and R&D centers where we can help you develop, and we have great products developed through our engineering teams and manufactured in our factories. So we look forward to showing you how some of our products and solutions can help you with today's challenges. So here's the agenda that we'll be running through today. Firstly, I'll begin by sharing some of the background and basics for plant-based and homogenization. Then we look at the parameters that influence homogenization effectiveness in plant-based beverage production. And then we'll take a view on some innovations and recently launched products and how we can help you through our innovation centers. And as mentioned, we'll finish with a question and answer session. So I'll begin by just sharing a schematic view of a beverage processing line, in this case, an oat-based beverage. And the details of the specific equipment and process will be familiar to those of you working in the industry, and I don't intend to get into too much detail here, but just wanted to share that the homogenization step traditionally comes in down here in the lower part of the schematic after the heat treatment and before the packaging and filling and packaging lines. So homogenization is an important part of current beverage processing lines. Also to say that at SPX Flow, we have most of the equipment and processes that you see here within our portfolio. But for those that we don't have, we work in partnership with many fine providers, so we can help you to design and complete the complete processing line, even if we don't have that equipment in our own portfolio. So let's take a look at some of the challenges that are faced in plant-based beverage processing today. Like all areas of food and beverage production, some of the key areas are listed here in terms of the product itself: taste, stability, color, flavor, viscosity, composition, all those things which give a fantastic product which is consistently produced day in, day out, has a long shelf life and a stability. And then you have the inputs, the raw materials, the processing costs, selection of materials for manufacturing. Again, consistency and cost are critical. And overlaying all of that is the regulatory environment and the expectations of industry, governments, consumers in terms of sustainability, flexibility, new product launches, and underpinning it, the safety of the products itself for the audiences that are consuming them. So we recognize these challenges. We see them in many areas of production, no different in the plant-based environment. and perhaps some additional requirements because of the expectation about segregation of plant-based products compared to some of the traditional products. So now let's start to talk about homogenization and what an homogenizer is. Many of you will be familiar what homogenizers are, so I'd like just also to remind of the basic principles. And with homogenizers, we talk about the physical part, but also the effect that it has. So we talk about a power end and a liquid end. And that's reflecting what we see here on the right in terms of an homogenizer basically being a pump with an homogenizing valve arrangement attached. The pump is a reciprocating pump, typically 3 or 5 plungers on production models. And that's driven via an electric motor and a transmission system, usually comprising of some gears or belts. And that pump effectively provides the flow of the liquid into the homogenizing valve assembly itself. Homogenization has a physical effect on the product. It can be shearing, it can be hydrodynamic cavitation, it can be turbulence, or a combination of those. And that physical effect is what causes the characteristics of the product passing through the homogenizer to change. And that's sometimes a misconception or misunderstanding, that homogenization is somehow adding or taking away from the product. It's not. It's simply changing the characteristics of the product in a way that's desirable, either for quality, consistency, shelf life stability. It can be a number of, or a combination of characteristics that are changed by homogenization. So that was the pump that delivers the product to the homogenizing area. Now let's take a look at what happens in the homogenizing valve assembly itself. The product is forced under pressure through a very small gap in the homogenizing valve, and that causes intense mixing and turbulence. And that turbulence and mixing releases energy very much locally within the homogenizing valve. And it's that energy that causes the effects of shearing or cavitation and dispersion that we talked about in the last slide. So there are various parameters that influence the amount of homogenization that takes place. It can be the geometry of the valve itself, the gap distance, the flow rate, of course, will influence what is happening as well, and also other things such as whether it's 1-stage or 2-stage homogenization, which is 1 or 2 homogenizing valves. So all of these parameters will influence what homogenization does in terms of changing the characteristics of a product. So here are some of the ways in which good homogenization can improve or enhance quality. And on the top here is the schematic of that area of the process line where homogenization takes place. That's after formulation and heat treatment and before storage and packaging. And the typical homogenizing pressures, because pressure is a key parameter with homogenization, are 150 to 250 bar total pressure. And then the secondary pressures, the 30 and the 50, are indicating if there's a second stage, which is typically used for stability. Some of the key quality improvements that homogenization gives are improving the stability through less sedimentation and separation of product, consistency of viscosity, and it can compensate for some variations in the premix, though good premix mixing itself is always required for homogenization. Improving the flavor through changing the characteristics. Improving mouthfeel and chalkiness, and that can be because of the particle size reduction and the dispersion of the various elements. Improving the bioavailability of the nutrients. The more the nutrients are opened up within the body of the liquid, then their availability increases. And the appearance can be improved either through color or luminosity, for example, on whiteness. Homogenization is known to have those effects. So many of these areas are well understood, but in the correct selection and application of the homogenizer, it can be optimized to some or more of these characteristics and quality improvements, depending on what's desired. Some examples of what that looks like in practice. Here we see from left to right, we have oat, quinoa, and wheat. And what you see in the pictures are the changes in particle size distribution viewed at a microscopic level from the top to the bottom picture. And generally speaking, with homogenization, we get a reduction in particle size and a better particle size distribution. And that in turn gives some of the characteristic improvements that I mentioned in terms of stability and consistency of taste and appearance. So here we see another example showing the improved stability for homogenization. In this case, it's a walnut beverage, which compares an unhomogenized sample and an homogenized sample after being stored for 1 day at ambient temperature. And you'll see on the before homogenization, the product is less consistent and showing signs of separation, whereas the photograph on the right shows a consistent product with no separation. The graphs are taken from these samples. The red is with homogenization, the green is without. And again, the stability improvement is seen in the graph in terms of the particle size reduction. And the two peaks represent the smaller one being the oil elements of the beverage and the larger one being the various solid elements. But all elements of the product are improved by benefiting from particle size reduction through homogenization. So here are some of the selection parameters that are used for correctly applying homogenization to your products. And the correct configuration maximizes the benefits, both for the product, but also to ensure a long operating life for your homogenizer itself. So firstly, we would look at the product details, for example, characteristics such as viscosity and the level of solids or abrasives that are in the product. And what that can influence with viscosity, it might mean that we need specialized feed systems or oversized suctions or particular types of suction valves, which needs to be carefully considered to ensure that the homogenizer is pumping fully. The best running homogenizer is one that's pumping at full efficiency and without any air or cavitation in the feed system. Secondly, the solids will influence, for example, the materials that are selected. We use harder materials such as tungsten carbide to give a longer operating life where we have solids and abrasive products. Of course, then the next category is the flow rate and pressure. That will depend on your desired capacity in the line, and the pressure governs the outcomes of the homogenization. Higher pressures generally lead to lower particle sizes. The homogenizing valve itself we touched on, but the geometry, the materials of construction, the gaps, these are all influencing the outcomes and ensuring that homogenization is effective. And then overlaid with that on the, getting back more to the pumping side and the engine, if you like, of the homogenizer, certain selections can influence water and energy savings. For example, the electrical efficiency of the motor, whether a frequency converter is fitted to ensure optimum operation, whether you choose to have automation of the utilities and water consumption. Those can influence the overall footprint in terms of utilities. We also need to think about compliance in terms of safety, in terms of food contact materials, whether on a global or a regional basis. And finally, one of the other characteristics is the type of controls, whether it's locally operated or remote automatic operation, which is more typical on larger process lines nowadays. So all of these selection parameters help to optimize the selection of homogenizers for plant-based processing lines, not only for the product outcomes, but also for the longevity of the equipment and for the water, energy, and utilities footprint. So now I'd like to share an example of an innovation that we're very excited about, and we welcome the opportunity to discuss with many of you. And this is around the improvement of a standard beverage production line to reduce the losses in solids and proteins. Here we're using oat beverage as an example. And on the top of the graphic here, we show a typical schematic of a process line with the fiber separation, removing the solids typically through decanters. And that process can heavily influence the losses in solids and protein, up to 30%, an example for an oat beverage line. Decanters are very effective in removing large insoluble particles, which must be removed in order to give the desired mouthfeel and stability and customer acceptance. But they're fairly indiscriminate in terms of removing a larger amount of protein, for example, which is bound up in the product. So the process which we show on the bottom part here is what we call a whole oat beverage production, where we replace the decanter with high pressure homogenization. We still have homogenization post heat treatment, but the earlier homogenizer step is designed to break up and make soluble some of the products and components within the plant-based liquid, which would normally be removed in a traditional process. The benefits of this process are listed below. And for example, you have a much more retained amount of solids and protein, up to 100%, depending on how the process is implemented. So you have more product gain, less waste, and therefore a more natural product as well in terms of retaining all of the original ingredients. Homogenizers are inherently clean as part of the line, so it's a more hygienic process, which is easier to clean. There's an improved nutritional value by retaining all of the original product. And it can help sustainability in terms of simplification of the inputs and outputs of the line. But of course, all of this is provisional on achieving acceptable mouthfeel and stability of the product. And this is where we will work with you, particularly with the selection of the enzymatic process upstream, to ensure that there's enough breakdown before homogenization that allows the homogenizer to give the desired effect on the product and not have anything taken away. So it's an example of how we can use homogenization to improve the current processes, have a more natural product with less waste. And we really welcome your contacting us to find out more about how we can help you to test and develop this process. Here's an example of some product that's been put through this process. It's an oat-based product where we see on the left, we have the graph showing particle size and pressure. And as mentioned before, increasing pressure will reduce the particle size significantly. You see the photograph in the middle showing the stability of the product. The one on the right has been homogenized, and it's showing a really consistent appearance. And then finally on the right, we have the microscopic details from unhomogenized to a number of different homogenized tests. And again, the increasing pressure shows a better particle size distribution and increased product stability. So again, we welcome you contacting us to hear more about how this process might be applied and to test your formulations in our innovation centers to develop this great process improvement. Now we'll just look at another innovation related to homogenizers, which may be of interest, and this relates to the water consumption. Here we offer the homogenizer water recycling system. It's a compact system which sits next to your homogenizer and recycles up to 97% of the water, which is used for cooling and lubrication of homogenizers. Many people don't realize how much water homogenizers can use annually because of that cooling and lubrication systems. And it hasn't been considered for recovery or recycling in many cases until now because the water has already gone down the drain. So this system keeps the water out of the drain. It sanitizes and filters the water and enables it to be reused on a continuous basis so that you're effectively in a closed loop in terms of the homogenizer water requirement. The drivers for this technology could be many in terms of initially thinking about conserving water as one of the world's most valuable natural resources. So it may be a sustainability driver. It may be simply due to the cost of water or water consumption goals that are in place in your plant in terms of the availability of water or supply constraints. It may simply be to have a more dry floor policy and to avoid water going down the drain, where then it can only be used for low-grade purposes if there is any treatment or recovery. So this system allows you to recover up to 97% of that water. It's fully automatic, it's retrofittable, and it's plug and play. So once it's installed, it can be running very quickly. And at no stage will it stop the homogenizer from operating. So again, please talk to us about this if this is of interest. And then to give you an example of one of our recently launched products, this is our Pilot 40 homogenizer, which is designed for small-scale tests or production. It's just an example of how we have recognized the need for a compact, self-contained unit, which is modular in terms of how it's constructed. And this modularity is driven by the key features of having interchangeable homogenizing valve stages, having the controls built in, having the variable speed drive built in. So it gives you a lot of production flexibility in one unit, and yet the ability to adapt for changing needs. Not specific to homogenization, just want to remind you of where we are around the world in terms of our innovation centers. And these centers are intended to help you design or develop or perfect your manufacturing processes and your recipes. We welcome customers to come and develop their recipes with us. Sometimes we develop for them and then share the results. And sometimes we rent equipment from these centers. Many options are possible. We would be very happy to discuss your needs if you don't have the facilities yourselves to develop product, or you just like to take it away to a separate environment where we can help you with our expertise. So again, reminder that this is a series of webinars that we're doing on plant-based processing. This is number 4. You see the full series here. You will find links in the communication materials to the other webinars, so please feel free to sign up for future webinars if this has been of interest. So just concluding the main part of the presentation before we get to the question answers, I'd like just to remind you that after the webinar, you'll receive the presentation material, and I'd also encourage you to take part in the survey. It really helps us to develop future materials, and want to thank you for joining today. As we get to the questions, let's see what's coming. Okay, so we have a number of questions. Thank you for those, and please keep them coming if you can think of others. So the first one here concerns the process which I mentioned about the replacement of the decanter. Yeah. So the question was, can the decanter be eliminated completely? Yeah. And the answer on that is not necessarily. The process that I showed is really designed where there are new formulations, where the recipes can be adjusted to enable the homogenizer to bring the product particle size particularly down to an acceptable level. So it's not immediately that it can be retrofitted to an existing process for current products. But what we have looked at, for example, is a combination of decanting and homogenization. So in one case, looking at, for example, 15% saving in lost material. So please talk to us if you have questions about those processes and how it could be applied. There's another question here. Is there a difference in lifetime for oats and dairy milk? And how does that look in terms of hours? That's a good question, thank you. So it really depends again on the recipe, and with the grain-based products such as oats, there are some particulates in the fluid which will have an effect on the lifetime of particularly the homogenizing valve parts. So to give an idea, the short answer I guess is yes, but to give an idea, with the dairy homogenizer, you might not need to replace the homogenizing valve parts for 1 to 2 years, 2 years in many cases. For plant-based product grains such as oats, then you'd want to be checking them after 6 months and maybe replacing them more like a year to a year and a half. So it's that sort of scale. It's not an absolute answer. It really depends on the formulation and the type of operation. Another question concerns the homogenizer water recycling system. How does it work? You can find more details on our website, but very shortly, it basically has a instrumentation on the water collection device, which checks conductivity, dissolved solids, and temperature. So then immediately you know if there's a leak or if there's water which simply can't be recycled. And in the water which doesn't fall outside of those standards, that gets sent back to the second skid you might have seen in the picture, which is the sanitation skid. And there it passes through a number of filters down to 5 micron. It passes through ultraviolet sterilization. That's what brings it back up to potable quality water. And then it passes through a heat exchanger to get to the desired temperature. More details on the website, as I mentioned. Thank you again for the questions. We have another one here, just concerning will the information be sent out afterwards? Yes, it will. We'll be sending out the information in the presentation to all of you who have registered. Thank you. Let's see here. Question concerning whether we have equipment available for rent and test. Yes, please get in touch with us through your contacts, and our innovation centres can be used either to test in-house or to rent equipment out. We have a question on the maximum particle size. I'm sorry, the maximum homogenizing pressure that's required, or the particle size. So again, that really will depend on the formulation and our tests on different formulations. We've carried out at a number of different pressures. So we've tested internally up to 1,000 bar, for example. That doesn't mean that you need to operate at those kind of pressures. And the particle sizes that we reach are dependent on the recipe formulation. They won't be as low as a traditional process where the decanting has taken away those fiber particles and other particles associated with them. So again, please get in touch to us and we can give more details. As I mentioned, the formulations have to be carefully adjusted in order to get an acceptable particle size. But we've done various morphology tests as well to check on not only the particle size, but how the particles and agglomerates are laid out. Thank you for that. I think those are, let us look. Okay, so there's a good question just come in terms of how does the CapEx compare two homogenizers versus one decanter and one homogenizer? It's a really good question, and also the OPEX, of course, is something that we would be looking at as well in terms of the total picture of the investment. So it really depends on the capacity of the line and the pressure required. Our initial results look like the CapEx is very favorable in terms of the overall investment for the second homogenizer rather than the decanter. And you couple that with the fact that you've got a more natural product where nothing is taken away, essentially. So that's that's how it works out. We would need to look at it case by case. So please get in touch with us if you have specific examples, capacities, for example, to show. Okay, I see we're got to the end of the questions that come in and we're running into the allocated time. I want to thank you again for participating and for the good engagement through the questions. Please do get in touch with us and we'd be very happy to talk to you about any of these topics. Have a good rest of your day. Thank you.